On this 2019 to 2025 Silverado 1500 with the 5.3 gas engine, P0102 often means the engine controller may be seeing a mass airflow signal that is lower than expected. The truck may idle rough, hesitate, feel down on power, or it may just turn the light on with no obvious complaint. Broadly, you're thinking about possible MAF signal issues, possible sensor power or ground problems, connector and harness faults, intake air measurement concerns, or a possible control side communication issue. Start with the basic system checks. Then follow a structured diagnostic approach and make sure you understand which diagnostic category you're in before you start testing. Don't jump straight to parts. Make sure you know whether this is a signal circuit problem, a power or ground problem, or a data problem before you make the call. Before testing, separate the monitor gates from the failure criteria. The monitor gates are battery voltage greater than 8.5 volts, engine running for greater than 1 second, engine speed equals greater than 300 RPM, and frequency the DTC runs equals continuously after the running conditions are met for greater than 1 second. For P0102, the setting point is MAF sensor equals less than 850 Hz for greater than 6 seconds. On the scan tool, the MAF parameter normal range is 8 to 20 Gs per second, 2700 to 3860 Hz. Use those numbers to understand the fault, but let the circuit tests prove the cause. Turn the ignition on with the vehicle in service mode. If other codes are present, check what they mean first and use the code pattern to choose the correct electrical path instead of treating every code separately. If no codes are currently set, idle the engine, slowly bring engine speed up to 3K RPM, and return it to idle. Then, review stored data and watch the MAF sensor parameter frame by frame. The value should not spike or drop out. If it does, go into circuit testing. If it stays steady, wiggle the harness and connectors at the multifunction intake air sensor and at the engine control module while watching the same parameter. If moving the harness or connector makes the value spike or drop out, repair the wiring, terminals, or electrical connectors as needed. If it still stays steady, reproduce the operating conditions or reproduce the captured conditions from the stored failure data and confirm P0102 does not reset. For the P0102 signal circuit path, power the vehicle down first. It may take up to 2 minutes for all vehicle systems to power down before an accurate ground or low reference continuity test can be performed. With the vehicle off, disconnect the B75C multifunction intake air sensor connector. Test for less than 5 ohms between ground circuit terminal 4 and ground. If that is 5 ohms or greater, disconnect the chassis ground and test between ground circuit terminal 4 at the component harness and the ground terminal for less than 2 ohms. If that second test is 2 ohms or greater, repair the open or high resistance in the circuit. If it is less than 2 ohms, repair the open or high resistance in the ground connection. If the first ground test is less than 5 ohms, turn the ignition on with the vehicle in service mode and test signal circuit terminal 2 to ground. You want 4.8 to 5.2 volts. If it is less than 4.8 volts, power down, disconnect the K20 engine control module connector, and test signal circuit terminal 2 at the component harness to ground for infinite resistance. Less than infinite resistance means repair the short to ground. Infinite resistance means check continuity from signal circuit terminal 2 at the component harness to the other end at the control module harness for less than 2 ohms. If that continuity is 2 ohms or greater, repair the open or high resistance in the signal circuit. If continuity is less than 2 ohms, replace the K20 engine control module. If signal circuit voltage is greater than 5.2 volts, power down, disconnect the K20 engine control module, turn the ignition on in service mode, and test signal circuit terminal 2 at the component harness to ground for less than 1 volt. If it is 1 volt or greater, repair the short to voltage. If it is less than 1 volt, replace the K20 engine control module. If signal circuit terminal 2 is between 4.8 and 5.2 volts, idle the engine and prove the module can see a signal response. Use the appropriate diagnostic test probe for best results, and expect that this action may need to be repeated several times. Connect a 3-amp fuse jumper wire to signal circuit terminal 2 at the component harness. Then rapidly tap the open end of the jumper to ground while watching the MAF sensor parameter. Keep B+ away from this circuit. Internal control module or component damage may occur if the circuit shorts to B+. While tapping, the MAF sensor parameter should be greater than 0 Hz. If it stays at 0 Hz, replace the K20 engine control module. If it goes greater than 0 Hz, test or replace the B75C multifunction intake air sensor. If this part of the diagnostic path calls for the high voltage signal, check again. Power down, disconnect the K20 engine control module connector, turn the ignition on in service mode, and test for less than 1 volt between signal circuit terminal 2 at the component harness and ground. If it calls for the normal signal window, check again, keep the engine idling, use the proper probe, repeat the action as needed, and verify the MAF sensor is greater than 0 Hz, while rapidly tapping a 3-amp fuse jumper wire between signal circuit terminal 2 and ground. If the return point is unclear, pause, recheck the earlier diagnostic path. Use the second electrical path when the code pattern points you toward the sensor's power, ground, and serial data side. Again, power the vehicle down first and allow up to 2 minutes if needed for the systems to go to sleep. Disconnect the B75C multifunction intake air sensor connector and start with ground circuit terminal 4 to ground. You need less than 5 ohms. If it is 5 ohms or greater, disconnect the chassis ground and test ground circuit terminal 4 at the component harness to the ground terminal for less than 2 ohms. At 2 ohms or greater, repair the open or high resistance in the circuit. Less than 2 ohms points to the ground connection. If ground is less than 5 ohms, turn the ignition on in service mode and verify a test lamp turns on between ignition circuit terminal 1 and ground. If the lamp does not turn on and the fuse is okay, power down, remove the lamp, and test ignition circuit terminal 1 to the output terminal at the fuse for less than 2 ohms. If that is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, verify the fuse is okay and that voltage is present at the fuse. If the lamp does not turn on because the fuse is open, power down, remove the lamp, turn the ignition on in service mode, replace the fuse, and verify the fuse does not open. If the fuse opens, isolate the load side. Disconnect components on that circuit as directed by the test path, or operate each component one at a time. It may be necessary to use a scan tool control function to operate a component. If a component causes the fuse to open when activated, replace the component that caused it. If the fuse opens with all components disconnected, repair the short to ground. If the test lamp turns on, connect a DMM from serial data circuit terminal 3 at the component harness to ground. The DMM should display between 3.5 and 12 Vs and fluctuate. If it is less than 3.5 Vs and does not fluctuate, power down. Disconnect the K20 engine control module and test that serial data circuit to ground for infinite resistance. Less than infinite resistance means repair the short to ground. Infinite resistance means test continuity to the control module harness for less than 2 ohms. If continuity is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, replace the K20 engine control module. If the DMM is greater than 12 Vs and does not fluctuate, disconnect the K20 engine control module, turn the ignition on in service mode, and test the serial data circuit to ground for less than 1 V. At 1 V or greater, repair the short to voltage. Less than 1 V points to the K20 engine control module. If the DMM is between 3.5 and 12 Vs and fluctuates, test or replace the B75C multifunction intake air sensor. After the repair, verify the repair and confirm P0102 stays gone. Keep verification separate from the pinpoint testing. First prove the circuit or component fault, then confirm the operating conditions no longer reset the code. Takeaway: P0102 is not a parts code. Prove the MAF signal, ground, ignition feed, data circuit, and connector integrity in order. For more diagnostic training, visit stepdiagnostics.com.